Okay, so we got Naya and we got Tyler signing on. Okay, Ty and Naya, can you hear me?
Yeah.
Okay. No, my audio is on. It's recording. Just want to make sure that they can hear. Okay, so we're going to finish up chapter 2. And then we're going to go into the lab. And my remote learners, I have put on in the classroom a virtual microscope lab that you should be working on. Okay, get these people out of the way. All right, so I think we stopped. Where did we stop? We stopped here. Polarity of water. Okay. So water is a polar molecule. Do you remember what that means? What? Opposite charges, right. There's opposite charges on either side of the molecule, right? The hydrogen side is partially positive, the oxygen side is partially negative. And that makes water a versatile solvent. Why? Yep. Right. Water will interact with anything that has a charge, either positive or negative, right? What kinds of things will not interact with water? Neutrals. Give me an example of something that's neutral. Oil, right? Oil has no charge. It's nonpolar, which is why it does not dissolve in water. Right? Okay. And we talked about surface tension, right? Okay, so we know that water forms hydrogen bonds, right? The hydrogen of one water molecule is attracted to the oxygen of the next water molecule, and that's a hydrogen bond. And hydrogen bonds are weak bonds. They're easily made but easily broken. But if you're talking about the surface of the water now, you've got all these thousands and thousands and thousands of water molecules, and they're all bound to one another. It almost makes like a molecular skeleton kind of thing, right? A molecular lattice on the surface of the water. And that allows something like this little water strider to skirt across the surface of the water without breaking the surface of the water. That's called surface tension. And that's another important property of water. And so then we said we all know ice floats, right? And why does ice float? Say again? The air? Right, and that's what you see in this picture, right? The bonds are more pulled apart, they're spread out, which traps more air, which invariably makes ice less dense, right? More buoyant, so it floats on the surface. Why is that important, that ice floats? Yep. So your fishies don't freeze to death, right? You get that nice layer of ice on the tops of the ponds and the streams, right? But below, that absorbs all that cold air. But then below, it allows the water to remain liquid. So we don't freeze all our fish and whatever aquatic life is in there. And then looking at another property of water, we said water is cohesive and adhesive. So cohesive means the water molecules stick to one another, right? They're going to hydrogen bond with one another. What does adhesive mean? Sticks to other things, right? So in the lab, when you're reading in your graduated cylinder, you always read from the bottom of the meniscus, right? Because water is sticking to the sides of the cylinder. So if you're a 30-foot oak tree, how does water get from the roots to the leaves? Say again? Pressure. Pressure from where? We're going to talk about osmotic pressure, right? There's water that is coming, right? Trees get water through their roots, right? Plants taking water through the roots. So there is a certain amount of pressure from that, but that's only going to get your water up maybe a foot. And my leaves are up here at 30 feet. Yep.
Isn't it so that like the water comes up and since it's coming out of the leaves, it like pulls it up with it?
Yes. Yes. Water is not pushed up. It's actually pulled up through the, see all these little tubes here? These are the vessels of the plant. So what happens is you can think of the water molecules as forming like a string of pearls. One hooks to the next one, right? And if you look at the undersides of leaves, you'll see that they have little pores there. They're called stomata. And that allows for evaporation, right? Water is going to come out through the leaves. But as one water molecule gets to the pore and evaporates away, it's pulling the water molecule behind it up. And that one evaporates and pulls the one behind it up. And that's how the water gets from the roots all the way up to the top of the tree. It's actually pulled up, it's not pushed up. Okay, and it can do that because water is cohesive and it's adhesive. It actually forms hydrogen bonds with the walls of the vessels to keep it from falling back down due to gravity. Okay, so those are very important properties of water. And here's a critical thinking question. We can answer this in class, you don't have to answer this for homework. But why does water freeze at a temperature lower than 0 when salt is added to it? Why does that lower the freezing point?
Because the salt like interrupts the water wanting to freeze it, sort of like unfreezes it, so it needs a lower temperature to like balance it.
Right.
And refreeze at the same time.
Right. The salt, the sodium and chloride basically get in the way of the hydrogen bonds. So it has to be really, really cold in order for that to freeze, right? The oceans don't normally freeze, right? But your freshwater ponds are going to freeze up, okay? So basically that sodium and chloride, those ions get in the way of those hydrogen bonds. And if you can't form those hydrogen bonds, you're not going to form ice. Okay? And then finally, at the end here, these are your 2 homework questions. And this is the way each presentation is going to go, right? We have the presentation, we'll have homework questions, and then vocab list. And this isn't a big vocab list, right? Come on. So you should be looking at these words already because it's Friday, right? Isn't the vocab quiz Friday? Yeah. Okay, so it'll take like 5 minutes. Yep.
Are these like this other questions posted online, or do we like write them down?
The PowerPoints are online. They're in Google Classroom. So you can access them anytime. Okay?
This thing.
That's all I want to go. No, this isn't working. Give me a minute. Okay.
Want to sign off? You can. This is recording, but you guys are all here, so I don't think I need to post it, but I will anyway at some point today. You guys, my remote learners, again, you should be working on that virtual microscopy lab. And just email that back to me when you get it done. Okay, any questions? No? Okay, we're signing off now because we're going to go back in the lab. You guys have a great day.
Thank you.